Okay, at this point, everybody should have out their homework assignment from last night, which was 12.3 or worksheet 3. If you can please have that out, I am going to go over a few questions at this time. So I have pre-picked a few problems to go over. The ones I've picked, let me label this. This is 12.3 worksheet 3. And the numbers I'm going over are 12, 20, 26, 27, 30, and 32. Starting off with number 12, log of 1 over 1,000 raised to the 4th power. Okay, in class yesterday I talked to you guys about, it's not an equation, it doesn't say solve, it asks us to evaluate, but in our head we think of it as our base to what power, and we don't know what this power is, so we call it x. So even though it's not an equation, we kind of make it into an equation so we can solve. Now, I said whatever this base is, there's no base there, and when there is no base, what does that mean? Correct, the base is 10. And we rewrite it. Remember, we wrap around the equation. 10 to the unknown power, which we call x, equals 1 over 1,000 raised to the 4th. Now we know in order to solve, we need to get them to have the same base. And any thoughts on what the same base is going to be? Correct, it's 10. 10 to the x equals blank to the 4th. Ignore the fraction for a second. 10 to what power is 1,000? To the 3rd, correct? So 10 to what power is 1 over 1,000? 10 to the negative 3rd. And I'm hoping that makes sense to everyone. 10 cubed is 1,000, so 10 to the negative 3rd is 1 over 1,000. And what do we do with the power to a power? We multiply. And since we have exactly one base on each side and they are the same, we can drop the bases and x equals negative 12. All right, in order to do the rest, I am going to write down the information, the given information. They gave us log of 4 equals m, and they also gave us log of 6 equals n. Now, second period, I didn't get to do one with you with the should know. I got to do it with my 6th period, but second, we ran out of time, so I want to make sure you guys are listening. When you're doing homework, when you're taking a quiz, especially when you're taking the test, and you have these type of problems, log of 5 equals k and log of 7 equals p or q or whatever letters they're using. First thing, pay attention to what the base is. The base in this case is 10, so log base 10 of 10 equals 1. And that should make sense. I didn't write the 10 because we know it's there. 10 to the 1st power is 10. And there's always going to be a should know. If the base were 5, then we would have log base 5 of 5 equals 1. If this base, say they used 8, then we would have log base 8 of 8 equals 1. In this case, since they used 10, and we know it's 10 because it's nothing there, log base 10 of 10 equals 1. All right, we're going to use that later. We're not going to use it on every single problem, but we will use it at least on 1 or 2 when it comes test day. So make sure you understand. All right, number 20. Log of 16. All right, so I'm going to put the log laws up here really quick. These are the log laws that were on your worksheet. So what we're going to try to do is rip apart our logs like this with addition, or with subtraction. So what we're going to try to do is use multiplication or division. And we're also going to try to use exponents, so we can use our exponent rule to bring it down to the front. So the three things we're going to try to use is multiplication, division, or exponents. Multiplication, division, or exponents, and we have to use our log laws. If we don't use our log laws, we've done something wrong. All right, is there any way to get 16 using 4 and or 6 using multiplication, division, or exponents? And I'm hoping everyone can see it's going to be exponents, because 4 to the second power is equivalent to 16. So I changed the way it looked, but I did not change the value. 4 squared is still 16. Now why do I do this? So I can use log law number 3, which allows me to bring that to the front. Remember log laws. Okay, so this becomes 2 log of 4. Again, it comes to the front, 2 log 4, and hey, look, log 4 is m, so 2m is the answer. It will take practice, and we will definitely be doing more of these. The next one I have to do is 26. Log of 2. Now, I believe I did this one with notes with you guys, but I'm doing it again because I know when I did it yesterday, there were a lot of confused looks out in the class. So, again, multiplication, division, or exponents using 4 and or 6. Okay, now obviously 4 squared is not 2, nor is 6 squared 2. 4 times 6 is not 2, 4 divided by 6, or 6 divided by 4. So I'm hoping you can think really hard and say, oh yeah, log of 4 to the 1/2 power. Now remember, exponents can be fractions, and you should recognize that a 1/2 power is equivalent to the square root. And the square root of 4 is indeed 2. Okay, so you really have to stretch your thinking on this one. All right, I can't multiply or divide these to get 2. 4 squared nor 6 squared is 2. So what about square roots or 1/2 exponents? Oh yeah, 4 to the 1/2 is 2. And we do this so that we can bring this 1/2 to the front like we did here on number 20 using log law number 3. 1/2 log of 4. And hey, look, there it is again. Log of 4 is m. So it's 1/2 m. Don't forget to use your log laws. For example, something like this, I will often have kids make this mistake on the test. They get that far, log of 4 squared, and they say, oh, well, if log of 4 is m, then log of 4 squared should be m squared. And that is wrong. It's not m squared, it's 2m. So don't forget, if you didn't use your log laws, you've done something wrong. Okay, so you shouldn't have any squares or 1/2 exponents. You should have coefficients. All right. Next one I have is 27. Log of 1 over 64. And actually, I'm going to cross out 27 and I am going to do 28 instead. Only because I haven't done one with the 6 yet. Log of 1 over 36. So again, instead of 27, I'm doing 28, and 27 is very similar to 28, so you can figure it out if needed. All right. How can I get 1 over 36 using 4 and or 6 with multiplication, division, or exponents? Now I can't say 6 plus 4 or 6 minus 4. It has to be multiplication, division, or exponents. And I can see that there's no way to multiply or divide these to get 36. But 6 squared is 36. Therefore, log of 6 to the negative second is 1 over 36. Do you guys see that? 6 squared is 36, so 6 to the negative second is 1 over 36. Again, I've not changed the value, I've only changed the way it looks. 6 to the negative 2 is still 1 over 36. And we've used this rule a lot, I realize that. We've used law number 3, which brings it to the front. Negative 2, log 6, and hey, look at that, log 6 is there. Again, you don't say, oh, log 6 to the negative 2 is going to be into the negative 2. It does not work that way. No exponents. And you have to use your log laws. So negative 2 n. All right, I'm going to move this off or cover it and do number 30. A log of 400. Okay, I'm hoping you can see that this is the one where we're going to have to use the should know. I haven't had to use it up until now. Does everyone agree that 4 times 10 squared is 400? I'm going to rewrite that. Do we all agree that 4 times 10 squared is 400? 10 squared is 100, and 100 times 4 is 400. All right, again, this should know we haven't had to use until now, but there will be some of the tests where you do need to use it, so we're getting the practice now. All right, this is log law number 1. Don't forget, you use your log laws. We rip it apart with addition. Log of 4 plus log of 10 squared log of 4 is m plus, bring your 2 to the front, 2 log 10, and there it is here, log 10 is 1, so I have m plus 2 times 1, which is simply m plus 2. Again, we first recognize that 400 is the same as 4 times 100, and 100 is 10 squared. Why am I allowed to use the 10 when I only said 4 and 6 earlier? Because that is one that we are allowed to use. It won't write it for us. We will need to write that one and know it on our own. Log law number 1, we break it up with addition. Log 4 is simply m. We bring our 2 to the front. 2 log 10 is 2 times 1 because log of 10 is 1. M plus 2 times 1 is m plus 2. Okay, 32. Log of 160. All right. I can see that this is log of 16 times 10. Why would I use 16 and 10? Because the 10's already there. And 16 can be rewritten as 4 squared times 10. And I'm going to give you guys a few seconds to continue that one on your own. I'll start you off. You're going to rip it apart using addition and then bring the 2 to the front. Go ahead and try that now. All right, I'm hoping everybody did log of 4 squared plus log of 10. Bring your 2 to the front. 2 log 4 plus log of 10. Again, I have to bring it to the front before I plug in. Log of 4 is m, so 2m plus log of 10 is 1, so 2m plus 1. All right, and while I'm at it, I'm going to go ahead and throw 33 in there, and then we'll be done. 33. Log of 20 over 3. Okay, this 20 over 3, how in the world can I use 4 and or 6? And I have this 10 as well that I can use. So how can I use a combination of these 3 numbers, 4, 6, and 10, using multiplication, division, or exponents to get 20 over 3? So here's the first thing I noticed, that 20 is the same as 2 times 10 over 3. Does everyone agree with that? 2 times 10 is 20, and then 3 stayed 3. All right. Now remember, multiplication is commutative, and I can kind of think of it as this: 2/3 times 10. 2/3 times 10. All right. Someone rewrite it. Log of 2/3 times 10. Okay, why am I doing this? A few reasons. One, I want to be able to rip this apart. Let me show you right now what I mean. Log of 2/3 plus log of 10. Why do I want to do that? 2 reasons. One, log of 10 I already know is 1, so that part is done. This is going to be 1. The other reason is 2/3, I'm hoping you can see, is equivalent to 4 over 6. Let me rewrite that. When you have 4/6, do you agree that you can reduce by dividing top and bottom by 2 to get 2/3? So once again, I've changed the way it looks. I have not changed the value. All right, so 20 over 3 is 2 times 10 over 3, which is equivalent to 2/3 times, and you can think of it as 10 over 1. 2 times 10 is 2 times 10, which is 20. 3 times 1 is 3. Ripped it apart using log law number 1. 2/3, log 2/3 plus log of 10. Log of 10 is simply 1, and I changed the 2/3 to 4/6 because it is the same thing. These two are equivalent fractions, and 4 and 6 are what I'm trying to use. All right, I have to rip this one apart. Log of 4, and it's division, so it becomes minus log of 6 plus 1. Again, log of 4 minus log law number 2. Log of 4 minus log of 6 plus 1. Log of 4 is m minus log of 6 is n. plus 1. We will definitely get more practice with these, and you do want to work on these because this is a part that kids struggle with on the test. Okay, so go ahead and put this aside and take out your notebooks.